Hey, fourth graders, back for another exciting episode of What in the World Are the Answers to My Assignment? Today's episode is Amplitude, worksheet number 5. Let's read through the text and then see how you did with your answers. The text says, the measurement of amplitude tells scientists about the intensity of a wave. How intense it is. Okay. In sound waves and light waves, amplitude is a measure of loudness or brightness. Loudness for sound waves, brightness for light waves. Moving on. When you turn up the volume on your music player, what are you actually doing? Scientifically, you are increasing the amplitude and the energy of the sound waves. Cranking that volume up, you're adding energy. You're increasing the amplitude. Bigger amplitude, bigger volume. If you compare sunlight with light from a lamp, sunlight is brighter because its amplitude is higher. So, higher amplitude for light waves is a brighter light. Lower amplitude is a more dim light. Moving on. In simple terms, amplitude, can't say that word, I'll try it again. In simple terms, amplitude, I got it, is the height of a wave. Amplitude is measured from the center of a wave to its highest point, the crest, we already know that, or the lowest point, the trough. We know that too. Generally, when the amplitude of a sound wave increases, its energy and loudness increases too. When a light wave has higher amplitude, the light has more energy and is brighter. Often, light with high amplitude can be harmful to people. Not supposed to look right at the sun, right? Yeah, that can hurt your eyes. Okay, let's move on down here. Number 1 at the bottom. What is the relationship between the amplitude of sound waves and loudness? Well, like it said in the text, generally, as the amplitude or the height of the wave increases, you have louder sounds, bigger volume. Higher amplitude, bigger volume, loud sounds. Number 2, what happens to a light that increases in amplitude? Increase the amplitude, the light gets brighter. Bigger amplitude, brighter light. Number 3, use the text to draw and label the amplitude of sound waves A and B. Well, we did that up here. As you can see for the top wave, I made a line with some arrows from the middle of the wave, that dotted line, to the crest. That's the amplitude of that top wave, wave A. And I did the same thing for wave B, from the middle, the dotted line, to the crest. So you can see the difference, for sure, between the amplitude of A and B. Obvious difference there. And now they're going to ask you a question about it. Number 4, which sound wave is louder, A or B? Okay, here's the amplitude of wave A, the amplitude of wave B. They're saying which one is louder. Well, remember what we just learned. The higher the amplitude, the louder the sound. So which one of these has a bigger or higher amplitude? Yes, you got it. Definitely wave A. A is louder, B is softer, as far as sound is concerned. Number 5, if A and B were light waves, all right, don't think about sound anymore. Now we're thinking about light. If both of these represent light waves, now the question is, which one would be brighter? Well, once again, remember what we learned. The higher the amplitude, the brighter the light. So which one of these do you think is going to be brighter? Oh yeah, I agree. Definitely A. A has a higher amplitude. That's a brighter light. B has a lower amplitude. Not nearly as high there, is it? So B is going to be a dimmer light. And the last one. Predict what would happen to the loudness of sound wave B if you flattened the amplitude to 0. So there's sound wave B. It's already shorter than A. What if you made that wave flatter and you flattened it all the way down to 0? That means so there's no amplitude at all. What do you think is going to happen? What happens if, to the loudness, if you take wave B and you make it amplitude 0, if there's no amplitude, if there's no wave height, you've got no sound. No sound at all. It's like you turned the sound off.